welcome back to Pocket Rock. Hey, where are you going? It's just math. Don't run away. Hey. Oh, well.
Okay, today we're going to be looking at trig ratio tables. In the last few lessons, we would actually find the ratio. We like say cosine is adjacent over hypotenuse. We would actually find a ratio and turn that into a 4 decimal number for cosine. So today we're actually going to find specific the ratio or a decimal for specific degrees. So you notice we don't have a triangle, so we're actually just finding specific. What is cosine of 86 degrees? Well, in present day, so we have these nice computers in our hand that we can actually do this on our calculator. But a long time ago, back in the day when they were sending people to the moon, they didn't have nice computers or calculators, and so they actually used tables to find what these actually specific numbers are. So if you look at 3b2, we're going to be finding cosine of 86 degrees using the trig tables, and then eventually we're going to be doing it on our calculator. And remember, trig ratios are to 4 decimal places.
Okay, this is what a table of trig ratios looks like in a book, and here we only have one page of it. Long time ago, there would be pages and pages, and so here are columns. You have degrees, then you have your sine column, your cosine column, and your tangent column. This is just a continuation of degrees. So over here, you start at 0 degrees, and the table goes all the way down to 45 degrees. And then you come back up over here, and so then you continue on with 46 degrees. So back in books where there would be pages and pages of these types of pages, you wouldn't just have whole number degrees. You would have like 40, you'd have like 1 degree and then 1.1, 1.2, 1.3, so forth. And then 2 degrees, 2.1, 2.2, and so forth. Okay? So here's how we use these. In 3b2, we were looking for a cosine of 86 degrees. So first off, let's go to our 86 degrees. So that would be over here. Our degree column is the first one, 86 degrees down here. And then sine was our first column, and then cosine was our second column. So here we are, cosine of 86 degrees would be 0.0698.
So cosine of 86 degrees, we found that that was 0.0698. Okay, now let's look at 3b3. Now we're going to find sine of 40 degrees on the trig tables.
Okay, now for 3b3, we had sine of 40 degrees. So you find your degrees, 40 degrees. Here's my first column is degrees, and then sine is my very first column. So here we are, this is sine, because it's my first, degrees is my first column. Then my next column would be sine. It goes in order, sine, cosine, tangent. So this would be sine of 40 degrees, 0.6428.
Sine of 40 degrees, 0.6428. Okay, now let's look at 3b4. We're wanting to do tangent of 22 degrees. We're going to find that on the trig tables.
Okay, on 3b4, we had tangent of 22 degrees. So the first thing you do is find your 22 degrees. Your degrees is your first column. Then the trig functions go in order of sine, cosine, tangent. And so tangent would be in the very last column, and so tangent of 22 degrees is 0.4040. And again, all of these can be confirmed in your calculators, but a long time ago, they didn't have calculators to confirm this. But now, in the present day, we can confirm all of these numbers in our calculator.
Tangent of 22 degrees, 0.4040. Okay, now we're looking at 3b8. So also we can go, we can do reverse. Here in this problem, we are given the actual ratio. Remember, ratio is just fancy word for fraction. A fraction can be turned into a decimal. So we are given the decimal value of sine, but we are wanting the degrees. So you can still use the trig tables to find that. So we can look this number up in the trig tables under sine, and then we can actually find the degree of what that is.
Okay, at 3B8, we're trying to find the sine, we're trying to find the degree, and we are given the decimal of 0.9986. So since we are at sine, so then your first column is your degree, then your next one is sine. So we need to look for these numbers until we find 0.9986. So keep going down, that's 0.9903, we're getting closer. Keep going, oh, here we go, 0.9986. So scoot over and our degrees will be 87 degrees. Just remember to look in the sine column for this decimal. So we see sine of 87 degrees is 0.9986.
So that would be 87 degrees. Okay, now let's look at 3B9. We're wanting tangent of some angle. We're finding the degrees here, equals 1.4826. So we can look up the 1.4826 on our trig tables.
Okay, in 3B9, we're looking for the tangent, and we are given the decimal of 1.4826. So we go into the tangent column. Remember, it's sine, cosine, tangent. So we're in this column of tangent column, and we're looking for the decimal of 1.4826. Okay, so those are 2 point something, so here's 1 point something, so here we go, 1.4826, and so we see that that degree is 56 degrees. So tangent of 56 degrees equals 1.4826.
And we see that that is 56 degrees. Okay, now we're looking at 3B10, and we're looking for cosine, and we're looking for the angle. So we know that that is 0.9925, so we can look up the 0.9925 on our trig tables.
In 3B10, we're doing cosine, and we're doing 0.9925. So we got to go to the cosine column, and we're looking for 0.9925. So remember, here's our degrees, sine, cosine, tangent. So here we need to be in this column here for cosine, and we're looking for 0.9925. So here we just need to keep going till we get to, here's one of the 0.9s, but we need to be 0.9925, and here you go, and we see that our degrees is 7 degrees. So cosine of 7 degrees is 0.9925.
And that would be 7 degrees. Okay, now we're looking at 3B11. How can we use the trig tables to determine what these angles are? Okay, so in this problem, we're actually trying to determine alpha and theta. Okay, so what they're asking you to do is they're wanting you to do sine theta in a fraction, then turn it into a decimal. And remember, those decimals are going to be to four places. So sine theta, sine is opposite over hypotenuse. So if we're standing here at theta, the side opposite of us, 4.85, and the hypotenuse is 5. So that is sine theta in a fraction. And so now we're going to turn that into a decimal. And so that would be 0.9700 to 4 decimal places. Okay, now let's do cosine theta. Cosine, standing at theta, is adjacent over opposite. The side adjacent to me, 1.2. Adjacent over hypotenuse. I think I said adjacent over opposite. Adjacent over hypotenuse, adjacent, and then hypotenuse is 5. So now let's turn that into a decimal. To 4 decimal places, that would be 0.2400. Now let's do tangent theta. I'm standing at theta. Tangent is opposite over adjacent. The side opposite of me is 4.85. The side adjacent to me, 1.2. Now let's turn that into a decimal. And that was 4.0417, rounding to 4 decimals. Okay, now we can look these decimals up on our trig tables. If we go into the sine column and look up 0.9700, then the cosine column and look up 0.2400, and then the tangent column and look up 4.0417, they should end up with the same theta values. And You may not find exactly the numbers, but they will be really close because of rounding.
Okay, so in 3B11, we found that sine of theta was 0.97, and cosine of theta was 0.24, and tangent theta is 4.0417. So we're looking for all of these numbers to where they're the closest. So sine, I look in sine theta for 0.97. Okay, so I'm going down, I'm trying to find something that's close to 0.97. Okay, so there we go. That's close to 0.9700. And then we said cosine was 0.2400. That's pretty close to that. And tangent theta was 4.0417. This is close. They're all going to be a little off because theoretically theta is not going to be a whole number degree. So since these are pretty close, then according to our trig table, theta is 76 degrees. Okay, we're just trying to find something that's close to all of them, so theta is 76 degrees. In reality, theta would probably be a decimal. It wouldn't be exactly a whole number, but going by the trig table, we're going to say theta is 76 degrees.
Okay, the numbers that match these three numbers the closest would be closest to 76 degrees. Now, if we were to put this in our calculator, we're going to see that it's not exactly 76 degrees, but right now we're just using the trig tables to round. So theta would be 76 degrees. Okay, so now we can do alpha. So now we're standing at alpha instead of at theta. Sine is still opposite of our hypotenuse. So if you're standing at alpha, the side opposite of you, 1.2 over hypotenuse. The hypotenuse never changes. And then turning that into a decimal, that would be 0.2400. Cosine alpha, standing at alpha, adjacent over hypotenuse, the side adjacent to me, 4.85 over hypotenuse. Turning that into a decimal, should be 0.9700. Tangent alpha, standing at alpha, opposite over adjacent, opposite of me, 1.2. Adjacent to me, standing at alpha, 4.85. Turning that into a decimal, 0.2474. And then something to point out, that the sine of theta is the same thing as cosine of the other angle. These are called cofunctions or complementary functions because theta and alpha are complementary angles. Since this is 90, these two have to add up to 90. And so these are called complementary functions or cofunctions, as we will learn in a few lessons. So sine of one angle is the same as cosine of the other angle. Same here. Cosine of one angle is the same as the sine of the other angle. So we can look up these values on the trig table. We can look under the sine column for 0.2400, the cosine column 0.9700, and then the tangent column for this, and to be able to find the degrees.
Now we can do alpha. Okay, we're looking for sine of 0.2400. So coming over here to our sine columns, let's find something that's close to 0.2400. Here we go, 0.2400. Then we said cosine of alpha was 0.9700. That's pretty close. Then we also said tangent alpha was 0.2474. Well, that's really close. So therefore, we can go ahead and go for to say that alpha is 14 degrees. This is the degrees. And remember, we want to choose a number to where those two degrees will be complementary and add up to 90 degrees.
Okay, the angle that matched the closest was 14 degrees. Again, these two angles should add up to 90 degrees. Since we have the other angle is a right angle, these two should add up to 90 degrees in order for our triangle to add to 180. Okay, so these two should add exactly to 90 degrees.